Good morning. I am back to read chapter 2 of How to Change Everything. I was thinking that I could take some notes or at least kind of set up how I would take the notes. I know last week we touched a little bit on it with the reading skill of the day, but your text features. So I wanted to kind of organize our notes and our thinking based on subheadings that are in chapter 2. So How to Change Everything, Chapter 2, World Warmers. To refresh your memory, this is the last paragraph in Chapter 1. Now that you've seen some of what young people are doing to call attention to the climate crisis, you may find yourself wondering what fueled their desire to act on such a large scale. The next chapters will give you a closer look at the climate crisis and its causes. You'll see what is driving so many kids like you to devote themselves to changing the world for the better. All right, here we go. Chapter 2. On Christmas Eve 2019, Antarctica got an unwanted gift, a new record. The ice-covered continent set a record for the most ice melted in a single day. Ice had turned to water on 15% of Antarctica's surface, but it hadn't been just one warm day. December is summer in Antarctica, the melting season, because seasons in the southern half of the world are the opposite of those in the northern half. But even in summer, so much ice had never melted so quickly before. By Christmas, the summer meltwater level had been 230% higher than the average for a month. Why? One scientist said that the continent had been significantly warmer than average all season. So again, here's another nonfiction text feature. We have some pictures. And then again, here's the caption that tells you what the pictures are showing you. Photos taken just 9 days apart in February 2020 show how much ice had melted at the tip of the Antarctic Peninsula after record high temperatures. So you can see the difference. Shows how much ice has melted in just 1 year. It's very interesting. At the same time, far to the north, where December falls in winter, the Russian city of Moscow had a different but related problem: no snow. For centuries, Moscow has been known for its winters. They are often bitterly cold, and snow usually falls before the end of the year. But in December 2019, temperatures were higher than normal. Gardens bloomed early. Children used ice rinks for soccer matches because there was no ice for hockey. City officials had to truck in tons of fake snow for a New Year's Day snowboarding event. And while this fake snow piled up in Moscow, unusual warmth was leading to climate tragedy half a world away. On the last day of 2019, thousands of people in southeastern Australia fled to beaches to escape the flames that were tearing through their homes and communities. Even though the southern summer was just getting started, already Australia was in the grip of yet another terrible heat wave. After 3 years with much less rain than usual, large areas were deep in drought. Trees and plants were bone dry, ready to ignite, and they did. Small fires started when lightning struck a dry tree or when people lit campfires, burned trash, or tossed cigarettes. Quickly erupted into massive fires that spread through areas of dry vegetation. Plants were not the only things that burned, however. As happens with many wildfires around the world, homes, businesses, and other human-built structures were destroyed or damaged as well. Perhaps the huge fires should not have been surprising. Just under a year earlier, Australia had started 2019 with its worst heat wave ever. In some places, temperatures had soared to above 104 degrees Fahrenheit for more than 40 days in a row. Then, too, fires had wreaked havoc. They destroyed vast stretches of ancient forest in the Australian state of Tasmania, which had the driest January ever recorded. When 2019 ended, at least 9 people in Australia had been killed by the fires. More than 900 homes had been destroyed, and more than 11 million acres of land had burned. Smoke and ash filled the air, darkening the skies even at noon. Tragically, about 500 million animals died because of the fires, including thousands of Australia's famous koala bears. Some rare animal species may well have been pushed into extinction. It would get worse during the following year's fire season. By the end of March 2020, 34 people were dead, more than 3,500 homes destroyed, more than 46 million acres burned, and 3 billion animals killed, harmed, or displaced. Oh my gosh, 3 billion. I can't even think about how many animals that is. That's really sad. Around the world, 2019 was a year of many such climate-related disasters and records. In Asia, the highest ever number of cyclones, fierce tropical storms, had torn through countries across the Indian Ocean. In the United States, floodwaters covered large areas in the center of the country, destroying crops and driving people from their homes. Heat records had been set across Europe and in Alaska. July 2019 was the hottest month on Earth since people had begun keeping records of temperatures. In September, the ice that had blanketed the Arctic Ocean for thousands of years at least shrank to the second smallest area ever measured. Almost a year later, Siberia, a traditionally cold region in northern Russia, was sweltering. In June 2020, temperatures hit 110.4 degrees Fahrenheit in the remote town of Verkhoyansk. I don't know. There was the highest temperature ever recorded in the Arctic. Parts of Siberia were hotter than Florida, alarming scientists around the world, and also fueling hundreds of intense wildfires. What did all these events have in common? Heat. All right, so this is the first section, so it doesn't necessarily have a subheading, but I think it's important to note some of these, some of the examples we heard of events that happened in 2019 and 2020. So events in 2019 and 2020. Okay, so I'm helping you kind of lead through these notes because on Wednesday, I want you guys to come prepared to discuss what happened in the first half of chapter 2. So we had Antarctica, melting season, Christmas Miller. Okay, so we'll put December 2019, Antarctica. The meltwater was 230% higher than the average. Okay. So there's a lot that you can put. I was just going to put a couple examples. You are free to put different ones. I want to put one about Australia because I cannot believe 3 billion animals were killed. End of. So we have March 2020. So they had 2 wildfires back to back, one in 2019 and one in 2020. 3 billion. Mm-hmm. 3 billion animals were killed. And 46 million acres. Burned. Burned due to wildfires. Okay, so that's all I'm going to put for my events. These two, one right, two. All right, now we are, so I like how it ends for that section. What did all these events have in common? Heat. So now the second subheading, we have heat and extreme weather. So I'm just going to go ahead and write that. So any notes I want to take in that section, it's nice and organized. Heat and extreme weather. All right. Floods and droughts, heat waves, and bitterly cold winter storms. How can heat cause so many different weather events? Good question. Heat waves are easy to understand. As temperatures rise, hotter days and nights become more likely, especially during summer or in places that are naturally warm. Hot days are especially important. When temperatures fail to drop significantly at night, heat waves keep building without relief. But heat also affects weather by changing the relationship between the Earth's surface and the atmosphere. As air heats up, it can hold more water vapor. Over land, warmer air draws more water out of soil through a process called evaporation, in which a liquid becomes vapor, that is, gas. Water leaves plants through transpiration, a similar process. During a drought, increased evaporation and transpiration make the drought worse by drying out the soil and vegetation. The unusually dry vegetation, in turn, is at higher risk of burning in a wildfire. Adding water vapor to the atmosphere intensifies other kinds of weather, too. The extra moisture means that when rain or snow does fall, it is likely to be heavier than usual, causing floods or severe snowstorms. Warmer air absorbs moisture through water as well as from land. As the atmosphere over the ocean grows warmer, it also grows wetter. One result of the wetter air over oceans, along with warmer water, is to make oceanic storms such as hurricanes, cyclones, and typhoons more powerful and destructive. Increased heat also changes the behavior of jet streams. These four fast-flowing air currents, one in each polar region and one on each side of the equator, occur where cold polar air meets warm tropical air. They usually move weather systems across the planet from west to east, but they can also twist or bulge south or north of their normal tracks. The cold Arctic region is heating up much faster than other parts of the world, which is likely weakening the northern polar jet stream, making it wavier. And as this polar jet stream twists southward, it carries frigid polar air and bitter winter weather with it. This helps explain why a planet that is getting hotter on average can still have extreme cold weather events in some places. Our planet is getting hotter. Sometimes this is called global warming, but climate change is a more useful term. That's because not every part of the world is warming all the time. The rising temperature of our planet is an overall average. Heat waves and storms have always happened, so have cyclones, floods, and wildfires. Now, though, we know that warming climate is fueling extreme conditions such as drought and extreme weather such as megastorms. Climate change makes deadly destructive natural events more likely. But climate change isn't just about new weather records or numbers on a thermometer. The warming of the world also brings many smaller, creeping changes to plants and animals, oceans, and more. In this chapter, you'll see what scientists have learned about the world's rising temperature and the changes that result. They are still working to fully understand these big and small changes, but the changes will touch the lives of all of us and all life that shares our planet. This is called climate disruption, climate change that disrupts or breaks up the way things have been all over the world. It brings new conditions that can be hugely destructive. The good news is that we know what is causing climate change, and because we have this knowledge, we also know what we can do to slow it down or stop it. And I want to go back up to my picture. And then, of course, we want to read the nonfiction text feature. We have a heading. We have a caption that explains the picture. And then a picture is also a nonfiction text feature. So a tornado left a trail of destruction in Joplin, Missouri in May 2011. Climate change will likely make such extreme weather disasters more frequent and severe. Isn't that one of the I Survived books? I think it is. All right, so now we're on to a different subheading. So I want to go and add to my notes. Okay. Okay. But heat also affects weather by changing. So I'm going to put the part about heat affects weather by changing the relationship between the Earth's surface and the atmosphere. Okay. All right, so that's about the more water vapor. All right, and then changes the behavior of jet streams. I want to put that. Heat changes the behavior of jet streams. And then so climate change makes deadly destructive events more likely. Okay. So heat and extreme weather. So heat affects weather by changing the relationship. Heat changes the behavior of jet streams. Climate change makes deadly destructive events more likely. That's what I'm going to include for the heat and extreme weather subheading. Now I am on the next subheading, Earth Today. All right. Let me see how long I've been. I'm trying, chapter 2 is really long, so I want to keep it short. Okay, I'm about 20 minutes. Okay, we'll do one more section. Wherever in the world you live, you and other young people today have something in common. You are seeing climate disruption happen and worsen as you grow up. During the 20th century, the climate across all the world's land and sea surfaces averaged 57.0 degrees Fahrenheit. In early 2020, the U.S. National Oceanic and Atmospheric Administration (NOAA) reported that the global average temperature in 2019 had been 1.71 degrees Fahrenheit warmer than that. In fact, 2019 was Earth's second warmest year on record, after only 2016. The 21st century is setting a lot of heat records. 9 out of the 10 warmest years on record have happened since 2005, 5 of them since 2015. You might not even notice if the temperature on summer afternoon went up by less than 1.5 degrees Fahrenheit or less than a degree Celsius. So if Earth warmed by just that much in 2019, is it a big deal? It is. To raise Earth's yearly surface temperature even a little bit takes a huge amount of heat. Because the ocean can store a lot of heat energy before the energy affects the surface temperature, that's why a small rise in average surface temperature represents a big increase in stored heat. That extra heat, says NWAA, is driving regional and seasonal temperature extremes, reducing snow cover and sea ice, intensifying heavy rainfall, and changing habitat ranges for plants and animals, expanding some and shrinking others. Greenland, for example, is a massive island between the Atlantic and Arctic Oceans. It is mostly covered by a thick ice sheet over a span of 5 days in the summer of 2019. Greenland's ice sheet lost 55 billion tons of water. The ice melted and flowed into the ocean. That was enough water to cover the state of Florida 5 inches deep. Scientists had not expected Greenland's ice to melt at that rate until 2070. Just a small change in temperatures can have big consequences. This is climate change and disruption in action. More than that, it is a call to climate action. All right, so let's take a couple of notes. That was a short section, but Earth today. So we want to put that the average temperature increase. So 2019. Well, let's just put 2020. So in 2020, the global average temp had increased by 1.71 degrees Fahrenheit. So in 2020, the global average temp had increased by 1.17%. Okay, so I want to turn it over. I know it mentioned it in the last subheading, but it also mentioned it in this one, so I think it's important that we understand the vocab word climate destruction. So climate destruction is climate change that disrupts or breaks up the way things have been all over the world. It brings new conditions that can be hugely destructive. So I'm going to put climate change that brings new conditions that can be hugely destructive. Constructive. Okay. I'm trying to think if I want anything else. Okay, so I'm going to say, I want to say 1.9. To raise Earth's yearly surface temperature even a little bit takes a huge amount of heat because the ocean can store a lot of heat energy. Ocean stores heat energy. Okay, so I believe this is probably going to be in the next couple of sections about how that's destructive to have this all that stored heat energy in the ocean, in the water. But we are going to stop there in chapter 2, and I'll release another video later on in the week. Bye guys, have a great rest of your day.